Hello guys, welcome back to my YouTube channel. I am your friend Mohammad Dinar studying in Sri Venkateswara College of Engineering. In this video, we are going to learn about block system, block diagram reduction technique in control system. Introduction: block diagram reduction technique is a method used to simplify complex control systems. Means to There are many complex control systems. To reduce into the simple control system, we use this reducing technique. It involves transforming a complex block diagram into a simple, simple one while preserving the system overall functionality. Third point, this technique helps in analyzing, designing control system more effective, simplifies simplifies the representation of complex systems for better understanding, help in identifying key components and relationships within the system. This is the control system. This here it is the summing point, and at last it is the takeoff point. At summing point it is RS, and at takeoff point it is CS. RS means Laplace transform of reference input. Here G of S, G of S means gain, means equivalent forward part. H of S, H of S means feedback part, transfer function. C of S, C of S means Laplace transform of controlled output. Here E of S, E of S means Laplace transform of error signal. There are many rules to convert a complex control system into the simple one. And in that first one, the associative rule. Me- Associative rule means it holds good for summing points which are directly connected to each other. Means there is no intermediate block between two summing points, or there is no takeoff point between the two summing points. As you see here, there is no summing, there is no intermediate block between the two summing points. So it is associative rule. We get the output as R1 minus R2 plus R3. Second rule, it is a blocking series. If the transfer function of blocks which are connected in series get multiplied with each other, means here G of n, G2, G3 are connected in series, means they are connected in series, so we have to multiply them. We have to remember in that there should be no summing point between them, no parallel. Blocks in parallel means the transfer function of blocks which are connected in parallel get added or subtracted according to the given signal with each other. As you see here, G1, G2, G3 are connected in parallel form. So by simplifying this, we get G1 plus G2 plus G3, or G1 minus G2 minus G3. Now here, for shifting a summing point before the block, we shifting this point before the G. So means by shifting the summing point before the block, and block have transfer function as reciprocal of transfer function of the block. Before summing point is to be shifted in the series with all the signals at summing point. See here, as you see here, C is equals to R G plus Y. When you shift this point to here, this when you shift this Y point, summing point before the intermediate block, in that we have to add the reciprocal of the intermediate block, means 1 divided by G. By simplifying this, we get R G plus Y. So this equation will not be changed, should not be changed. we have to keep it in mind. Shifting summing point after the block means first we have seen shifting the summing point before the block. Now we are going to see the shifting the summing point after the block. While shifting the summing after the block adds a block having transfer function same as the block, after which the summing point is to be shifted in series with all the signals at the summing point. As you see here, when we shift the summing point after the block G, the same block is gonna added. It is not visible, but it is same gonna added with the summing point. Okay, shifting takeoff point before the block. While shifting the takeoff point before the block adds a block having transfer function same as the block behind which take off it to be shifted in series with all the signals taking off from that takeoff point. Shifting takeoff point after the block. While shifting the takeoff point after the blocks at the block in the series with all the signals which are taking off the point having transfer function as a reciprocal of transfer function of block behind which take off to be shifted. Means shifting this point after this, as I told you, it gonna be reciprocal of it. Removing minor feedback. It is the very important role. We have to keep it in mind because this rule gonna help in further modules also. Taking out the minor feedback loop in a control system involves eliminating a smaller loop that provides a feedback within the larger system. This adjustment can help simplify the system and improve its overall performance. As you see here, summing point, block, h of s. To eliminate this, we will get the output as g of s divided by 1 plus g of s into h of s. This is the eliminated part. Eliminated output came from this. Okay, this is very important. We have to keep in the mind. Shifting shifting takeoff point after summing point. Shifting takeoff point after summing point. It means moving the location where the signal is extracted to a different position after it has been combined with other signals. It is not as much as important, but also we have to look after it. Takeoff point before summing point. The shifting of the takeoff point before the summing point means changing the location where a signal is extracted before it is added to other signals. Procedure to solve block diagram direction. Now we have seen what are the rules. Now we are going to see how we can implement the rules. Okay. Step 1, reduce the block connected in series. First, see the block diagram, control system diagram. See which of the connections are connected in series and make them in a series connection. Reduce it to series. Second, step 2, reduce the block connected in parallel. Okay. Third, reduce the minor internal feedback loop. As I told you, the very important rule, reduce it. Step 4, as per as possible, try to shift takeoff point to the right and summing point to the left. Unless until it is the requirement of the problem, do not use rule number 9 and 10. As I told you, rule number 9 and 10 we have to not use, but if the requirement is there, we have to use it. Okay. Step 5. Repeat the step 1 to 4 till simple form is obtained. we uh, we are we will see in the next slides how we can simplify a complex control system into a simple one. Okay. Step 6, using the standard transfer function. Using simple closed loop system, obtain closed C of S loop transfer function C of S by R of S of overall system. Keep in the mind C of S by R of S. Okay. Now the concepts discussed in the previous chapter are held. Okay. Block diagram reduction rules. As I told you, there are some other rules also. Same. Rule 1. Check for the block connected in series and simplify, as I told you. Rule 2, check for the blocks connected in parallel and simplify. Okay. Rule 3, check the blocks connected in feedback loop and simplify. Rule 4, if there is difficult with takeoff point while simplifying, shift it towards right, as I told you. If there is difficult with summing point while simplifying, shift it towards left. Repeat the above steps till you get the simplified form. You can refer these rules or that rule. Okay. The transfer function present in the single block is the transfer function of overall block diagram. Note it down. Okay. Now it is now we will see. Consider the block diagram shown in the figure. Let us simplify or reduce this block diagram using the block diagram reduction rules. Okay. First, as I told you, this is the complex block diagram. We have to make it into simple one. Step 1. Use rule 1 for blocks G1, G2. See, this is G1, G2 connected in what type? Series. Okay. Now make this multiply this both of them G1 and G2. Okay. Simplify the block diagram using the reduction technique. After the multiplying, you will get this. Okay. Now what you will do? Step 2. Use rule 3 for the block G1, G2 and H1. Use rule 4 for shifting takeoff point after the block G5 using the block diagram technique. As I told you, the very important rule, minor loop rule, to convert, to eliminate this, we will get the output as G1, G2 divided by 1 plus G1, G2 into H1. See? Okay. As here mentioned, use rule 4 for shifting off the point after the G5. See here, to eliminate means to put this point after the G5, we will get the output as I told you. H2 is the common here, divided by reciprocal of the block present to the left of it. Okay, you will get it. Use now step 3. Use rule 1 for the block G1 plus G4 and G5. G1, G4, G5. This is connected in series. Okay. After modifying this, we will get in this type. Okay. Now step 4. Use rule 4. Block G3 plus G4 into G5 and H3 are connected in minor loop. After converting that into a minor loop, we will get this G3 plus G4 G5 divided by 1 plus G3 plus G4 G5 into H3. Now see, this is also the similar as step 5 means these both of the blocks are connected in series. So we have to convert them, reduce into series form. After reducing this in series, we will get a form. This form, after multiplying this both of them, because it is connected in series, we will get this form. After getting this form, this is what I told. Minor loop, important one. After converting it into the minor loop, we will get the equation as this. Therefore, the transfer function of the system is, for the y of s is g of s by r of s is equal to g1 g2 by g5 into g3 plus g4 divided by 1 plus g1 g2 h1 into 1 plus g3 plus g4 into g5 into h3 into g5 minus g1 g2 g5 g3 plus g4. When you solve this, you will gonna find this type of the reduced transfer form. Thank you for watching my video. Please like and